In this interactive video, you will learn more about loads and constraints. Now it is time to think about constraints and loads. Again, take your time and think about likely errors. Where are the loads coming from? How can you effectively apply constraints to your model? Before we are actively creating any loads or constraints, we need to generate a load collector. The first load collector will be named constraint. Let's assign a nice color. We choose purple. For simple load scenarios, no card image needs to be defined. Note: a load collector folder is now displayed in the model browser. Constraints are created via the BC's panel in the menu bar. To more easily pick the nodes, which will be constrained, we are zooming in, by using the Control key at the same time as the mouse wheel. Next, we are going to select the node which will be constrained. As explained in the video about the graphical user interface, DOF refers to degrees of freedom. DOF 1 to 3 are translational displacements in X, Y, and Z directions. DOF 4 to 6 are rotational displacements with respect to the X, Y, and Z axis, respectively. Here, the translational displacements of the selected node will be constrained. Let's focus on the node on left side of the brain. All DOFs of this node will be constrained. To display or hide the constraint symbols, or to cross-check whether the constraints are located in the correct load collector, activate the icons next to the load collector. Depending on whether the constraints are applied on nodes or on geometry, one of the icons needs to be. The size option controls the symbol size of the constraints. Note: you can change the symbol size at any time. You may even re-enter the panel at a later time. We now pan and rotate the model in such a position that the nodes, which will be subjected to external forces, can be selected in a convenient way. We are not allowed to place constraints and forces into the same load collector. Otherwise, the finite element program will prompt an error message. Therefore, an additional load collector needs to be created. The additional load collector will be named forces. Here we choose red. Note: the newly created load collector named forces is currently the active collector. Do you remember the meaning of a current or active collector? Now that the collector has been created, we can create the forces. The nodes at the tip of the bracket are selected by using the Shift button in combination with the left mouse button. Next we define the magnitude of the force. Per each single node, 5 newtons should be applied. To better see which axis is pointing upward, we are rotating the model slightly. Please note, our selection is not affected by the rotation. It is clear now that the positive z-axis is pointing upward. So we switch the direction of the forces to the z-axis. As the forces are supposed to act in a downward direction, we need to change the sign of the magnitude to -5 Newton. Note the message in the message bar. The force with a magnitude of -5 newtons is applied to 19 nodes. As with the constraint symbols, the size of the force vectors can be adjusted at any time. Depending on the local situation, all force symbols may be displayed in the same size, or they may be scaled according to their magnitudes. What do you think? Did we apply the forces correctly? Let's zoom in and have a closer look at the force distribution. Something that should catch your attention is the force distribution along the edge. All forces act on two element edges, respectively, except the forces applied to the corner of the bracket. Hence, the corner nodes experience a load twice as high as the other nodes along the edge. As you can see, it is very easy to create modeling mistakes. Finally, we carry out a visual check. This ends the video about constraints and loads. Still, we are not done with this topic, as we need to define the so-called load step or subcase, as shown in the corresponding video. For further reading and training exercises, please view the help menu. Also, don't forget the starter kit manual, which also contains information about this very topic.